Hello, my name is Raj, and we'll start the lab 1. Right now I'm on my home directory. I'll change to the my lab 1 directory. Okay, first of all we'll see the shred command. I have nothing on my lab 1 folder. I'll create one file using echo command, echo, and I'll say is echo. I'll say hello in my file test.txt. Now my test.txt has hello world, or just hello. Now if I see ls tst, it will give you the information of the file, like how many bytes is it when created, all that, read, write. The shred command is used to securely delete the files from the file system. Shred is used to overwrite a file with random data several times before it is unlinked, making it harder to recover the data through forensic methods. And when we go and look it up to the PPTs, here we have V for showing the progress, Z for overwriting with the zeros, and N for overwriting N times. If I use the same command for shredding my file, it will be shred V and VZN3 and test.txt. It will try to passes all the condition and do randomly again one more time, and will overwrite my file with 0 before unlinking it. Now we will download an image and try upon that. So the image link is this. I'll copy it and paste it on here. Paste. Paste. Enter. Okay, let me see if it's downloaded or not. So we have successfully downloaded a picture. I'll say display to view it, and we have a image here. Now if I run the same command, the shred command, for this picture, it will do all the tests. And now if I try to display the image, display 66, will be magic. Okay, so it successfully did his job. Now we'll go and look into our main file which we will work on. I'll download the zip file which we are working on for the rest of our project. Let me see if it's downloaded or not. This is a file which we are working on. It's a zip file. We'll do unzip it. Okay, so from this file we got Rhino 2 log, Rhino 3 log, Rhino log, Rhino USBDD, which is the driver which we are working on. We'll first copy it into another file before working on it, because it's a best practice and it will help us if we did something wrong or something went with the data. It will help us to save the original data separately from what we are working on. and this is the file which we created. Now once we do that, I'll show you the OpenSSL command, which will help to create hashes, the MD5 form of all the types. So if I do for rhino.log, I'll get this one. If I do same for rhino2, I'll get a different one. If I do for rhino3, I'll get different, and same for the rhino USB. USB did it. Yep, I got a different one. Then we'll use fdisk command on our rhino USB.td. fdisk command is used to list the partition tables of all the disk drivers currently detected by the system. So we can see the partition here. Now we'll do mmls command on the rhino USB. mmls rhino USB.td, and mmls command is used to display the layout of partition on the volume, which is include details about the starter section, end section, length, description of each partitions. Helps to understand the partition layout for accurate recovery and analyzing of data. It helps digital forensics to determine where the data resides on the disk and how the disk is originally organized. Then once we do that, we can do part rhino USB.td. Now if I do print, it will print everything. The part rhino USB.td command lines is used in the Linux for managing disk partition. It allows users to create, delete, resize, and manage disk partition on various storage devices supporting multiple disk formats. So our disk is FAT16 type. I'll use quit to get out of it. I spelled wrong. Okay, we are still on the same folder. Then I'll do fstat speed. Okay, so I did fstat command that will show file system detail and statistics, including layout size and labels. Here the -b command is used to indicate block size, and -o command is used to indicate the image offset. Then it's fls-o-0 rhino USB.td. So we just implemented the fls command. The fls command is used to list file and directory within an image of a file system. Here the -o command is used to specify the offset of a file system. FL is used in the forensics investigation and data recovery scenarios. These orphan files are the files that are deleted but still have some metadata in the file system, but they are not seen or accessed from the root directory. Means they are hidden for now, but we will use some tools to get the data from it. For doing that, we'll do fls, so we'll get everything here, the missing images uses. For there we'll say display detected entries only means command -d that's used for displaying the deleted entries only. If we use -r, that is recursive on directory entries, and -u is used to display undeleted entries only. If we replace, so on the above example we did -o. The -o was used for image offset. So in place of that, if we use any of this, we'll get a different results. Now we'll recover the Rhino images from the DD. What's a PhotoRec? PhotoRec is a powerful recovery software that is used primarily to recover lost images, lost files, lost video, lost documents. PhotoRec is used in a situation when the data has been accidentally deleted or system has become corrupt, but the physical storage medium is still mechanically functioning. It is valuable tool for both casual users who have lost their data and for professional tech ITs or professional digital forensic researchers who are trying to recover data from various digital storage medias. Let's first create the copy of our disk. So for doing that, I'll use disk if command rhino usb.dd off. I'll name my file as rhino usb my copy, all caps, and I think it is done. So this was my original file and this is the copy of it. If I do the hashes, I should get the same because it's the same copy, so hash should be the same. See, each of this file has a different hash because they all are different, but if I'm getting a copy of this and doing a hash of that, I should get the same hash. So for referencing, I'll do the hash of this again, and I'll also do the hash of my copy one, and as said, the hashes are same, so it should be because a copy of hash is always the same. Now once we do that, we'll try to recover the photos from our copy USB drive, and it will ask me some commands. Which disk? This disk. We know it's FAT16. It's not there because it's a FAT16. We know that. We need to get images from the free disk, and if I say select for C, because it says select for C, so double checked, and I'll say C. 132 files is saved in this directory are recovered and completed. I'll do quit, then I'll do quit one more time, and if I list, I should have one more directory here. So recup directory has all my recovery files from my free space. Now we'll see how many files are in recovery dash files. So this many files, but the images are only this one, and we got two different GIFs. So if I only want to display the JPGs, so I'll do ls -l means list anything before the dot, doesn't matter, but after the it should be jpg. Oh, I never changed the directory. Change to this, now ls, and now I'll do the command. Okay, I have 1 2 3 4 5 6 7 different images. Let's see what kind of images we have. So for displaying it, we'll use display command and the name of the file, which is 10, which should autocomplete. Okay, so we got one crocodile for the first one, so that's not rhino. For second one, we also got crocodile, that's not rhino. Okay, third one is also not rhino. Okay, this is also not rhino. Okay, we got one rhino image, which is from file 106393, which is this one, just this one. Okay, where did it go? Okay, I need to close it and go back. Okay, now 6393 64, and this is also a rhino image, so we got two rhino images, and last one is 33, and that's not a rhino. We have two more GIF images, so if I want to display GIF, I'll do that. Anything before point doesn't matter, but after point I need GIF. I have two GIFs, let's display those. I'll do that. 68 68 65 dot. Okay, we got one more rhino. Do the same. 68 89, and that's also a rhino. So we got 4 rhinos, 2 from here and 2 from here. So with help of Photorec, we recover 4 rhino images, and that's all for today. Thank you.